Okay, ji, so transformation, we will be doing reflection, which is lecture number 2 now. Now, considering transformation, as I have discussed in the lecture 1 as well, the transformation is changing each point of object to each point of image. Transformation is to change each point of object to each point of image. Now, for reflection, we'll be using the same strategy of transforming the object to the image. But considering there are types of reflection. Your types of reflection includes number one, reflection with respect to x-axis, reflection with respect to y-axis, reflection with respect to y is equal to x, reflection with respect to y is equal to minus x, reflection under any given line. X is equal to 1, x is equal to 2, x is equal to 5, y is equal to 3, y is equal to 7, y is equal to 9, or any y is equal to mx plus c. So reflection can take place under any given line such that x1, x2, x is equal to 2, x is equal to 3, y is equal to 3, y is equal to 7, or any etc. That means depending upon the question as well. Now, let's just work upon reflection with x-axis because each of the reflection is important. So when we do reflection with x-axis, there's one thing that we need to understand, and that is when we are reflecting through the x-axis, your object is transformed to image. Your object is transformed to image using what? Your x coordinate will be same, but sign of y coordinate will change. If it is positive, it will be negative. If it is negative, it will turn to positive. With this thing, what reflection is, you need to understand this point, which is important. Your reflection is importantly changing object to image using mirror line, reflection line, or line of symmetry. These are the three words which can be used when the reflection is done. So reflection is only possible using what? Mirror line. Reflection is possible using the reflection line. Reflection is possible using the symmetrical line. So, when we talk about middle line, reflection line, and symmetrical line, what is more important is your distance. Your distance of object to reflection line will be same of image and reflection line. That means the distance will be same of the object and the reflection line and the image and the reflection line. But this will be on the opposite direction. This will be in the opposite direction. Now, let's just work through the x-axis. Then when we talk about reflection in the x-axis, your x coordinate is same, but the sign of the y will be changed. So, particularly, let's continue this with an example question. So here we have an example question in front of us. So let's just say that this is your object, right? And this object is being transformed with respect to the x-axis. So if it is being transformed with respect to the x-axis, what we see is that the object point from the x-axis to the reflection line, because the reflection line is your x-axis, this is your reflection line. So since the object distance from the reflection line is 1, let's say this is A. So the image distance from the reflection line in the opposite direction will also be 1. So at this point, this should be A dash. For this point B, again, your object distance from the reflection line is 1. So the image distance from the reflection line in the opposite direction will also be 1. The object distance of this point from the reflection line is 1, 2, and 3. So the image point from the reflection line will also be in the opposite direction, 1, 2, and 3. So this clearly means that if we just say that one distance, let's mark this thing as A, this thing as B, and this thing as C. So the distance of A is 1. So the distance of A dash will be in the opposite direction. With the same distance will be 1 as well. So this becomes your A dash. Your B distance is 1 from the reflection line. But in the opposite direction, it should be B dash. Your C distance 1, 2, and 3. Distance is 3. So in the opposite direction, it should be 3 as well. 1, 2, and 3. So this point will be what? C dash. So considering this, that this is your reflection image, because it is reflected now. This was your object and this was your image. Now each point of object has been transformed to each point of image. Now what important here is, let's say that A is 1, 1. So what we discussed was for A dash, there should be the x coordinate will be same, but the sign of the y will be changed. So this should be 1, -1. Your B was 2, 1. So B dash will be your x coordinate is same, but the sign of the y coordinate will change. For C, this was 1, 3. For C dash, this should be 1, -3, because the x coordinate is same, but the sign of the y coordinate will change because of the reflection with respect to the x-axis. So whenever there is a reflection with the x-axis, your x coordinate is same, but the sign of the y coordinate will change. And each point when we draw up, we got to know that this becomes what? This becomes your image, using what? The distance of the object from the reflection line to the distance of the image to the reflection line. Considering this as object and this as your image. So this is your particularly translation, or sorry, reflection with the respect to what? Reflection with the respect to x-axis, which says that your x coordinate will be same, but the sign of the y coordinate will change. If it is plus, it will go to minus. If it is minus, it will go to plus. But remember, we can directly use the graphical method as well. Your distance of the object to the reflection line will be same as the image and the reflection line, but in the opposite direction. Okay, Ji. So now reflection with x-axis. So reflection with y-axis. Now considering reflection with y-axis, your object is transformed to the image, but in this case, you need to understand your y coordinate remain same, but sign of x coordinate is change. If it is positive, it will be changed to negative. If it is negative, it will be changed to positive. So reflection in y-axis, your y coordinate remains same and the sign of the x coordinate is changed. But we can always consider this as, remember, your reflection is through the mirror line and the object line. And here, middle line and the reflection line. So here at this point, you need to understand that your middle line and reflection line is basically y-axis. So the object coordinate from the reflection line will be same as the image coordinate from the reflection line. Your object coordinate and your image coordinate from the reflection line will be same. So here's the shape or the graph that we will be solving. Let's just say that this is your object given. This is your object given in which you need to reflect it with the what y-axis. If I need to reflect with y-axis, let's just do it directly first. Now considering that there are three coordinates, one is A, the other one is B, and this becomes C. Your A is 1, comma 1, your B is 2, comma 1, and your C is 1, comma 3. If I want to do directly, so what we did was we understood that your y coordinate remains same, but the sign of the x coordinate is changed. So if we just write down a dash, so your y coordinate will remain same, but the sign of the x coordinate will change. So it will be minus 1, comma 1. B dash will be minus 2, comma 1, and C dash can be minus 1, comma 3. That means your y coordinates are same, but the sign of the x are changed. Now, when I talk about the sign and the coordinates, let's just work upon them. Let's just say that this point is your A, this is your B, and this is your C. So we need to understand that this becomes what? Your y-axis. This is your y-axis line. Your object needs to be transformed to the image. Your object needs to be transformed to the image. Now let's just say that the object A, point A, distance is 1. So with the respect to y-axis, this distance will be on the opposite side of the y-axis. So if the distance is 1, then obviously on the opposite side, the distance will still remain 1 because it is the reflection with the respect to what? Y-axis. Now, the distance of B from the y-axis is what? 1, 2. How many points? 2 points from the reflection line. So obviously it will be 2 point opposite as well. 1, 2. So this point will be what? B dash. This becomes A dash. This point becomes what? B dash. Similarly, if you just look at C, C is here. So if I just say if C is this point, then with the respect to this, on the opposite side, it should be also 1 point. So right hand side is 1. So on the left, it should also be what? 1. So this becomes what? C dash. So considering this, let's just mark down just draw the triangle. So the reflection triangle, that means your triangle A is mapped onto triangle, let's say B, with the reflection using the y-axis. And the coordinate of y remains same, but the sign of the x changes. Just look at A dash here. Your A dash here is minus 1 comma 1, minus 1 comma 1. Your B dash here is minus 2 comma 1. And your C dash here is, if you just see, minus 1 comma 3, and these are the same coordinate that we have here. A dash was minus 1 comma 1, B dash was minus 2 comma 1, and C dash was minus 1 comma 3. So we can directly do them using what? Your y coordinates are same, y coordinate are same, but sign of the x coordinate are changed. Sign of the x coordinates are same. So considering the same aspect, remember this important thing, that each point of the object is changed to each point of the image. So when each point of the object is changed to each point of the image, we will always be considering the answer with respect to the points, with respect to the points. So that we can have the answer which is required for a particular question. Moving further with the topic, now let's just work down with reflection with y is equal to x. Now, considering reflection with y is equal to x, you need to understand that your coordinates are interchanged. Your coordinates are interchanged here. Now, when we say coordinates are interchanged, what does that mean? That particularly means that any particular x will become your y and your y will become x. So that clearly means that if we have 2, 3, that will become 3 and 2. So coordinates are interchanged. That means your x coordinate will become y for image. And your y coordinate will become x for image. Now, but with the respect to y is equal to x, this is very important for you to understand that y is equal to x reflection line will always have coordinate what? If x is 1, that means y will be 1. If x is 2, y will be 2. If x is 3, y will be 3. If x is 4, y will be 4. This will be used when we have what y is equal to x line. That means whenever the line of reflection line with respect to y is equal to x is drawn, your reflection line will have coordinate 1, 1, 2, 2, 3, 3, 4, and 4. And then eventually your coordinate will interchange with respect to that. We'll be going forward to the working example. I thought of not changing the diagram that we were using because this diagram will give me an interesting image considering y is equal to x. Now, knowing the fact that the equation is y is equal to x, right? So reflection of line y is equal to x needs to be drawn. For that, what particularly thing that we know is that y is equal to x means if x is 0, y is 0, x is 1, y is 1, x is 2, y is 2, x is 3, y is 3, x is 4, y is 4. So this line becomes the reflection line considering what? The equation of reflection line is y is equal to what? X. So that means for any particular y is equal to x equation, if the coordinate is 1, x is 1, then automatically y becomes 1. If x is 2, y becomes 2. If x is 3, y becomes 3. But as we particularly said that the reflection is what? Reflection is when we particularly look at the distance of the object coordinates, and the same distance will be applied to the image coordinate but on the opposite side. But what does it opposite side mean? That means if the reflection line was like horizontal, if the object coordinate is here, then what we did was image coordinate needs to be here because of the same distance. If the reflection line is this and the object is here, so the distance will be same as for the image. This is horizontal and this is vertical. But now you need to understand this is your diagonal reflection line. This is your diagonal reflection line. So the image will also be created diagonally. The image and the reflection will also happen diagonally. So when it says diagonally, so what does this mean? This particularly means that if I say that this is your A, this point becomes B, and this point becomes C. So since the reflection line is passing through the object itself, since the reflection line is passing through the object itself, your A will be opposite to the A itself to become A dash. So the distance here is half. Distance here is half the coordinate. So particularly I can directly say, okay, this particular image will be on the opposite side to have what? A dash. So let's just change the color so that it is important for you to understand. So A will become what? A dash here. Since your B is on the reflection line, it will still remain same because there is no distance from the reflection line. So image will have no distance from the reflection line as well. But if you look at C, C is on the left hand side diagonally, so it will go towards the right hand side. So opposite to C is here. So that means if diagonally it is 1, so opposite it will be 1 as well, and this will become what? C dash. So your object becomes your image diagonally with this reflection. So this is your reflection considering the object is on the reflection line. That means your right hand side coordinate shifted to left, your left hand side coordinate shifted towards right diagonally. The point on the reflection line will still remain on the reflection line. It will not be changed. The point on the reflection line will remain on the reflection line because obviously, since you need to understand that the object distance is important from the reflection line. Since the object distance is 0, so the image distance will also be 0. Knowing the fact that we already knew that A was given to us, right? A was already there, and the coordinate of A is 1, comma 1. Coordinate of B is 2, comma 1. Coordinate of C is 1, comma 3. So the coordinate needs to be interchanged. The coordinate needs to be interchanged, right? So if we just look at this, considering the expect, need to shift the coordinates because we changed the coordinates eventually. So let's just write down according to the question that we took. We took A as 2 and 1 in this, not 1 and 1. We took B as 1 and 1, and we took C as 1 and 3. So now your A dash from what? 2 and 1. Your A dash from 2 and 1 became 1 and 2. Coordinates got interchanged. Your A dash becomes what? From 2 and 1. From 2 and 1, it becomes 1 and 2. Coordinates got what? Interchanged. Similarly, your B dash, since it is 1 and 1, it will still remain 1 and 1. Because if you see, the coordinate is same. So on the line, it will still remain same 1 and 1. Even if it is interchange, it will remain 1 and 1. For C dash, it will be 3 and 1. Your 1 and 3 coordinate that was 1 and 3. This was your object coordinate C becomes the image coordinate as 3 and 1. Because the coordinates got what? Interchange when the reflection is happening with the line is equal to y is equal to x. Now, since obviously considering the same diagram, let's just work it down. Work it down like this. If the diagram is given to us, And the diagram is like this. This is your object. Let's say this is your object. Now, considering that I need to change this object to image. Now, this object has to be changed to image. Now, if this is object, let's say this is C. Let's say this is C. This is D and this is E. So, if C is 1 comma 4, your D is 3 comma 4 and your E is 3 comma 5. So if I directly want to write down the reflection point, this should be 4 comma 1, D is 4 comma 3, right? And E will become 5 comma 3. This was 1 4, then this was 3 and 4, and this was 5, 3 and 5, right? So considering that these coordinates are interchanged, so 1 4 becomes 4 1, 3 4 becomes 4 3, 3 5 becomes what? 5 and 3. With respect to this, now you need to understand. If I just look at the distance, your E distance from here is diagonally with 1. E distance is diagonally 1. The object distance from the reflection line is what? 1. So the image distance from the reflection line will be diagonally what? This becomes E dash. E was 3 and 5. Now E dash is 5 and 3. E dash is 5 and 3 because the coordinates are interchanged. Similarly, your D was what? D was 3 and 4. Your D was 3 and 4. Now 3 and 4 becomes what? 4 and 3. This becomes what? D dash. Similarly, C was 1 and 4. Now, knowing that this distance is half and 1, diagonally we can use it half and 1. That means your C dash comes here, which was 1 and 4, now becomes what? 4 and 1. But diagonally distance, if you look at this, 1 and half, on the opposite side, half and 1. So this point, this becomes your, this thing becomes what? Your image of the object that was given with the reflection line of y is equal to x. So we need to consider when the diagonally reflection line is there, we will be diagonally reflecting it with the reflection line. Or when the coordinate, when the distance or the equation line is given y is equal to x, we will know that the coordinates will interchange. Your 1 and 3 will become 3 and 1, your 4 and 5 will become 5 and 4, your 7 9 will become 9 and 7, your 10 and 10 will become 10 and 10 because that 10 and 10 will be on the reflection line itself. So the coordinate on the reflection line does not change, it remains same. But if the distance of whatever the object is given will be taken into consideration from the object, then the image distance will also be taken into consideration from the reflection line. So this was particularly reflection in the y is equal to x. Okay. Moving further with reflection with y is equal to negative x. But before that, what we have done already up till now is reflection with x-axis. Reflection with x-axis does what? It changes, x coordinate will remain same and the sign of the y coordinate will change. Reflection of x-axis is there. Remember the distance of the object and the image is same from the reflection line. Reflection in y-axis, your y-coordinate is same, but the sign of the x-coordinate is changed. The y-axis is this. The object is on the opposite side to its image. Reflection with y is equal to x. The coordinates are, remember, interchange. Your 2, 1 becomes what? 1, 2. Your 1, 1 becomes 1, 1. Your 1, 3 becomes 3, 1. And the example that can be given is that since there is the diagonal reflection line, then automatically the image will also be go diagonally. So let's just work upon the reflection with y is equal to minus x. Considering that y is equal to minus x, your reflection, your coordinates are interchanged. Your coordinates are interchanged. as well as sign, as well as signs are changed. Example to this, let's say that we have 1 comma 3. So a dash will become 3 comma 1, but the signs will change. This will become minus 3 minus 1. If b is 5 comma 4, so b dash will be 4 comma 5, but the signs will also be changed as negative 4 and negative 5. Now moving on with the example of reflection of y is equal to minus x, we should know that if x is negative, if x is 1, then y will be negative 1. If x is 2, y will be negative 2. If x is 3, y will be negative 3. So this will give me what? Reflection with y is equal to x line. So if I just want to have the reflection line considering the same aspect of the question, let's just say that we have, if this is 1, then y will become minus 1. If x is 2, y becomes minus 2. If x is 3, y becomes minus 3. If x is minus 1, then y becomes 1. If x is minus 2, y becomes minus 2. And in this way, you will have a diagonal reflection line crossing from y is equal from the origin. And this will be y is equal to what? Minus x. Now, looking at the object itself, we should understand that the object distance of origin to, let's say this is A, this is B, and this is C. So, your diagonally, there is 1 unit difference diagonally. So, obviously, diagonally, there will be 1 unit difference. So, this will be A dash. Diagonally, there is, if you just see, there is 1.5 distance. Diagonally, there is 1.5 distance. So 1.5 distance. So half and 1 distance will come here, which will become B dash. If you just see the C coordinate, you have diagonally 2-point distance. So diagonally we will have 2-point distance of becoming what? C dash. So at this point of time, you need to understand that diagonally the reflection of line y is equal to minus x will give me the diagonal reflection of the image as well, which becomes A dash, B dash, and C dash. Here, what we know is that A is 1 and 1. So A dash will become what? Minus 1 comma minus 1, which is C minus 1 and minus 1. B is what? 2 and 1. The coordinates are interchanged as well as the signs. So minus 1 comma minus 2. So C minus 1 and minus 2 is here. Similarly, if I see the C coordinate, which is 1 and 3, and if I need to change this should be 3 comma 1, which will be minus 3 and minus 1. So eventually we have minus 3 and minus 1. So whenever we have y is equal to minus x reflection line, the coordinates are interchanged as well as the signs are interchanged, keeping in that mind. But remember, when you have a horizontal reflection line, when you have a horizontal reflection line, you will always have the horizontal reflection. Similarly, if you have vertical reflection line, you will have vertical reflection. But if you have a diagonal reflection line that we have in this question, we will have a diagonal reflection, considering we'll be counting diagonal distance from the reflection line and the object point. So this was your reflection under y is equal to minus x. Now, you need to understand one particular thing. That is that your original matrix of any coordinate is 1, 0, 0, 1. Your original coordinate matrix is 1, 0, 0, 1. Now, we will always be taking what? An x-axis and the y-axis coordinates that we have. So whenever we have reflection in x-axis, the x-coordinate will remain same, but the sign of the y-coordinate will change. Because this thing is important, considering that we know that this is 1, 0, 0, 1. But with the reflection with x-axis, the x-coordinate is same. Considering, let's say this is your x-coordinate and this becomes your y-coordinate. So if I say we have coordinate with x, this will remain same, but the sign of the y will change. That means the coordinate, matrix coordinate for reflection of x-axis is 1 0 0 minus 1. With respect to reflection with y-axis, the original is 1001. The original is 1001. But reflection in y-axis, if we just write down 1001, this means that this should be considered as reflection. Your y coordinate remains same, but the sign of the x is changed. This will be changed to negative, but your other one will remain same. That means y will remain same, but your x sign will change. Then when we have reflection with y is equal to x, we know that coordinates interchange. So when the coordinates interchange, 1001 will be 0110. This will be 1001 will become what? This will be 0110. This is your original, and this will become what? Y is equal to what? X. Similarly, when we have reflection in y is equal to minus x, 1001 is your original. It will be changed to what? Your coordinates are interchanged as well as the signs are interchanged. 0 minus 1 0 will become what? Your y is equal to minus x matrix, where this becomes the original matrix of any coordinate that is given. So these are the four matrices for the reflection. 1001 is the normal matrix for any coordinate. Your reflection in x-axis will become what? The x coordinate is same, but the sign of the y will change, so it will become 100 minus 1. Similarly, when you have reflection with y-axis, y coordinate sign is same, but the x coordinate sign is changed, so this will become minus 1001. When you have y is equal to minus x, so when you have 1001, this will become 011 and 0. So moving forward, because the coordinates are interchanged here, and then when the coordinates are interchanged with the respect to y is equal to minus x, your signs are also interchanged. So 1001 will become 0 minus 1 and 0. Considering that if there is any reflection with any other particular line, let's just say that we have a line which is y is equal to 7. So this line will be y is equal to 7 because this is what changing y is equal to 7. So y is equal to 7 means horizontal line, x is equal to 3 means vertical line. So if just say that this is your x-axis and this is your y-axis, let's just say. So this is 3. So the horizontal line, your vertical line will become x is equal to 3. And let's say this is 9. So this should be y is equal to 9. So whenever you have horizontal line, this will be y is equal to 9. And you have vertical line, this will become x is equal to 3. So the coordinate, the line, reflection line will be given to you in different ways. So if for suppose the reflection line is just as that if it is here, let's say the reflection line is y is equal to 7. This is your reflection line. And knowing the fact that the object point is here. So what we need to do now, the same thing that the when we had reflection in x-axis, what we used to do was reflection in the x coordinate is same, but the sign of the y changes. That is not applicable here because now the reflection line is changed to what? Y is equal to what? 7. So for these kind of equations, when the reflection line is there, we need to just count how many distance. What is the distance? 2 points. So 2 points on the opposite point. So this will be your a dash. So for the object, what you need to do is with any different equation of line is given, we just need to count the object distance from the reflection line to the image distance from the reflection line. And then you will be able to solve the equation given in any other form other than the reflection with x-axis, y-axis, y is equal to x, y is equal to minus x. Your reflection under any given line will be used through the distance of from the object of the reflection line through the distance of the image through the reflection line. Most of the question we'll do it with the example questions when we'll be working down in the past papers. But at the moment, that is just to explain you that the distance will be counted for the reflection under the line. One thing that is remaining is in this part, in this reflection video is the reflection line when object and image is given. We need to find out the reflection line when the object and the image is given. When the object and image will be given, the question will ask you what type of reflection is, what type of transformation is that. So with that, we will be working down when we will be covering down the rotation. After the rotation, we will be covering down the reflection and the image reflection line and the rotation point, because these 2 points are linked together. So that will be under the video lecture number 5. So this is about it from the topic reflection, which covers reflection in x-axis, y-axis, y is equal to x, y is equal to minus x, reflection matrices, and reflection under given any other given line.